negative 4? What do you mean?
I put the point on -4.
So is negative 4 a point? Is a point one number or two numbers? Two? Okay, so where'd you put your point? What's your x value and your y value?
My x is 4 and -4.
Your x is 4, and your y was what?
-4.
Negative. Okay, so it was right there.
Yes, sir.
Okay. So did you have any other points, or was that the only point you put?
Oh, that's the only thing they had on my phone.
Okay, so but that point is on. Let's look at this boundary line. So what is the boundary line we're looking at here? So is the boundary line an inequality or
This ended up having.
is the boundary line an inequality or is it an equation?
Equation.
Equation. So our boundary line where y equals -4.
Yeah,
Okay.
that's the page you look at.
So why is this line right here y equals -4?
There should be, yes, 2 pages.
What do we think?
You already have the homework. Last week.
So how do we know that this line right here, how do we know that's y equals -4 for the boundary line? What do we need to make that true? So we don't really have, so in this situation, we don't really have,
That's the y-intercept?
so what, yeah, so what would our y-intercept be right here?
-4, 0.
-4, 0, okay, so that's what that y-intercept is, but we don't have a slope since it's just a horizontal line. So
That's number 4.
what do all of these points have in common? They're solutions, so this one is at -5, -4, this one's at negative,
Oh, so it's supposed to be a cross? I mean, horizontal line?
yeah, it's a horizontal line, so that, what all these have in common, the y value is always -4. So the x values can change, but that y value is always -4. So that's why at y equals -4, it's a horizontal line. I know that sometimes it's a little confusing because the y-axis is vertical and the x-axis is horizontal, but for y equals -4, it's going to be horizontal, so that all those points are a solution since the y value is -4.
Cause I did like a dash line. Like when my point at 4 and -4, I did a dash line.
Okay, so right here we do have a horizontal dash line. Why is this line dashed?
Because it can be equal to.
It can be equal to? So remember, when we're looking at the boundary line, we're looking at the equation. But now, when we're deciding dashed or solid, we look back to the inequality. So, what does this inequality tell us about whether it should be dashed or solid?
It's less than.
Is it less
I mean,
than?
greater than.
It's greater than, okay. So if it's greater than,
Can't be equal to.
it can't be equal to, right? So if this line was solid, it had to be equal to. Since it's dashed, that means on this line, it's not a solution to this inequality. So that's why it's dashed. So then why is it shaded above the boundary line? Why? Why is it above the boundary line? What do you think? So we have y is greater than -4. Why do you think you would shade that above the boundary line?
Because everything greater is above.
Because it's greater, exactly. So for greater, it's going to be above the boundary line. Now, if you're unsure of that, you can test a point that's above the boundary line to make sure that that's a solution. Because what we're doing when we shade is we're just shading all the solutions to this inequality. So if I took the point 0, 0, which is in this shaded region, and I plug it into our inequality, is 0 greater than -4? No?
Oh,
0 is.
Yes. So now we know that that's correct. We know that we shaded the correct region. Does that make sense? And what about, how did we do on number 2 and number 9?
I got number 2 correct.
I ain't even do them two.
Didn't you do number 2? Okay. Trey, how did you do number 2?
Look at the y-intercept is 5, negative 5.
Okay, so let's do the y-intercept.
Then the slope is 3 divided by 5. So
Mhm.
rise over run 1, 2, 3, 1, 2, 3, 4, 5.
Does everyone see what he did? So this is in, what form is this in?
Slope intercept.
Slope intercept, which is y equals what?
MX plus B.
Mx plus b. So your b, or your y-intercept is at -5, right?
Yeah.
And your m, like I said, is rise divided by run, or 3 divided by 5. So up 3, to the right 5. So then you make your boundary line, but why is this boundary line solid instead of dashed?
Because it will be equal to.
It's going to be equal to, it's less than or equal to, right? So then why did we shade downwards, or below the boundary line?
Because they would make it true.
It would make it true, right? Because it's less than or equal to, okay? Are there any questions on number 2 before we move to number 9?
Sometimes I be getting the line and stuff like dotted or solid.
Yeah, so for dotted or solid, just always look back to the original inequality, and if it can be equal to, it's solid every time. If it is only like greater than or less than, it's dashed every time. That's where you want to look for that.
For number 9, how like the y-intercept -5?
So how'd you get the y-intercept to be -5?
I'm asking.
Oh, you're asking? Okay, so how do we're looking at, so what form is this in right here? If we had the boundary line, which is what? What is the boundary line? Remember what we said over here, the boundary line? 3x minus 2y, is it less than 10? Or, that's the inequality, right? So what about the boundary line? Kind of like what we said for number 4. The boundary line is always what? Remember, we're looking for the equation of the boundary line.
So
Exactly. So, equal to 10.
equals,
Okay, so now, based on our notes, and you can look back in your graphic organizer, what is a strategy we can use if you're wanting to find this y-intercept? What do we know about a y-intercept, and how can we find it from this equation?
we know that it's gonna be 0. The
What's
x-
going to be 0?
X value, so we do 3, and then replace the x with 0.
So you know that x is 0, right? So you have 3 and then times 0, minus 2y equals 10. So then what do we do from here?
Divide. Okay.
So is y equals -5, is that enough? Is that an intercept?
No, I have an x value,
And what's our x value?
0.
Yeah, so 0, negative, so that's the y-intercept, right? Which is where they got that point on the graph right there. So now, what about x-intercept?
The y value is going to be 0.
Y is equal to 0, okay, so 3x minus 2 times 0 equals 10. So then, what does that give us as our x-intercept? 3.5. So you get 10 divided by 3, which is also 3.3 repeated. Which that's something you can use your calculator for if you don't know it off the top of your head. So that's where they get that x-intercept right there, which is just a little past 3. So, does everyone see how we found those intercepts from standard form? Yes, no, maybe? So now let's look at the borderline. Why is the borderline dashed in this situation instead of solid?
Because it's going to be
Because it can't be equal to, so this is we're looking at only less than, so the solutions will be on the line. So, but now, how do we know where to shade in this situation? Because we have 3x minus 2y is less than 10, but it's shaded above the boundary line. So how do we know where to shade?
Cause everything set up and everything,
Everything's shaded up as less than 10. How do you know that? How could you test that?
point,
A point, okay, so let's look at an easy one. Let's look at 0, 0. So if I plug in 3 times 0 minus 2 times 0 is 0 minus 0 less than 10.
yes,
So that is true. So that shows you that this shaded region above the boundary line are the solutions. But my original inequality has less than, and for less than, it usually shades below the boundary line. So what's happening there?
because the division by.
Wait, dang, I was gonna ask you something, but I forgot. Never
When you
mind.
think about it, ask me. What were you saying?
Divided by negative,
Divided by a negative. So when you subtract this 3x, and you get negative 2y is less than negative 3x plus 10, and then we divide that negative 2, just like we did for the boundary line. When we divide by a negative, what happens to the sign of the inequality?
you gotta flip it, you know.
It reverses. We'll make sure, so the sign reverses, but then it becomes y is greater than 3 over 2x minus 5. So then, this is also another way, if you don't, both of these are valid. You can either look at the standard form and find the intercepts and create the line how we created it, or you can convert this standard into, what form is this in right here?
So, answer,
Slope-intercept form. So now you can say, well, the intercept is at -5, which we talked about, and then the slope, we have that slope, and we can create the line from that, and then greater than, we know to shade above.
Alright, I remember now. This is about number 4.
Four?
What I had did number 4 on the homework, how are you supposed to know, like which way to you know how that's like straight across?
The boundary line?
Yes, sir. How are you supposed to know when it's supposed to be straight across?
So like we talked about, of all these points right here, -5, -4, -2, -4, what do all those points have in common?
A -4?
That -4, that y is always equal to -4, right? So that's how you know that line needs to be horizontal, because if I created a vertical line at this -4 over here, all these points have an x value in common. That x equals -4.
One detail I want to slow down and really emphasize, because Dawn, you did respond, you said they all have a -4. But is that -4 in the place of the x value of the point or the y value of the point?
Why?
Notice, and like Mr. Lipham pointing out, what is the equation for the boundary line? What equals -4?
well,
Wait, what? Yeah, why?
See how it's y equals -4, and you just said every y value has what value?
-4.
Does that make sense?
Yeah, cause I don't know why I did the boundary line like that.
Here's what I will say. Don't make it about a horizontal line. Don't make it about a vertical line. Make it about what points make the equation true, right? Y needs to be -4. It doesn't matter what x is. Y always needs to be -4. Does that make sense? Okay, well, we gotta keep going.
Yeah.
We are behind.
I just wanted to.
Yeah.
Oh
So,
yeah, can I do number 2 and 9
Well,
Well,
they're on the board.
for half credit?
No. I forgot to mention earlier, I will say if you do your homework tonight, because I made this deal in an earlier class, then I will replace the grade that you made today. So if you do your homework tonight, you justify everything, it means you get a 5 out of 5 tomorrow, and I will replace today's grade with a 5 out of 5. So do your homework tonight. What are you doing? Like, why are you upset, Dewan? Like, this is giving you a better option.
no homework,
So, we are going to look at the vocab organizer that we actually pull out. So, the first thing I want you to do is to write down the proper definitions for both solutions for systems and for standard form of a line. And so, once you have written the proper definition, you're gonna come down here and write this section, and then beneath that, this note. So, right now, we're not looking at vertical lines and horizontal lines.
I got a question.
Yep.
Was that homework too?
No, this is just what we're doing right now.
Do my pen.
So, all of this information that I'm currently circling, this is all about standard form of a line. We know some about vertical and horizontal lines that we were just talking about, but we're not gonna fill that part out yet. So, all of this information is supposed to go with standard form of a line. Does everyone understand that?
That's the proper definition.
Yeah, so write these proper definitions, and then come over here and write this right here, and then this note should go under that. And this is always standard form of a line. We just ran out of room. If you have any questions about how it's supposed to be organized or what something says, just ask.
So all of that right there for standard form.
Yeah, all of that that just circled, that all goes under standard form of a line.
So we won't put enough for vertical and horizontal line?
No, yeah, we're not putting anything, we've talked about that a little bit, but we're not gonna fill those out completely yet. So don't put anything for vertical and horizontal.
Oh, I did it because we had it. I think we had it for homework.
Yes, you did already have it for homework.
Yeah.
What he's saying right now is,
Don't do it.
write this down if you are missing any of these details. Right, so you need to look at what you already have and then add extra information if you're missing any of it. Now, no one should have the proper definition because I never ask you to fill that out on your own. Mr. Lipham.
And it's another way of writing like inequality of a line.
Say again?
The standard form of a line is just another way of writing the equation of a line.
That could be your personal definition, the proper definition's on the board. So the personal definition is the second column, the proper definition is the fourth column. If you have the fourth column filled out, you done messed up. To save time since we're behind, instead of doing the two off of the sheet that they're working on, let's just do the new sheet. So go ahead and jump into top of it.
Safari, I thought it was
How can we, we'll do it by hand, but then let's check it with the Inspire. Check it should have both not necessarily just the tail end, we should hopefully save enough time that they discuss perfectly. And you come together, and then we talk about it, and then you check it with the Inspire. Yeah, does that make sense? No, yeah, 100%. No, I think you're right, but then we have to adjust other parts of the instruction.